more than once, let's say, repetitively, like walk from their house to their fields or go visit their neighbors. All this stuff eventually, subtly, but eventually gets embedded right into the surface of the Earth, sometimes in very complex ways. And so my colleagues and I tried to essentially read these landscapes to get at a whole realm of material culture and patterning and things produced by peoples of the past that most people kind of ignored until fairly recently. And what attracted me to the Amazon part of Bolivia, so this is the northeast corner of Bolivia, were features such as these where you have agricultural platforms. These are raised fields. I'll talk about them in a little more detail in a minute. They could extend to the visible horizon. And if you fly over these sometimes, you could be traveling in a small airplane and have the pilot go fly low if I'm paying for it and photographing out the window. And you can go literally for 20 minutes sometimes and not see a break in these patterns produced by the prehistoric peoples of the past. And what these people are doing in probably any area of the world where humans have interacted with their environments is a concept we call domestication of landscape. And so in the Amazon, they domesticated few animals, a wide range of tree crops and plant foods that they domesticated and farmed, but didn't have the range of, say, animal species that you find in Africa, Asia, or Europe, if you look at the prehistory. But what they're doing is they're changing the environment. So they're not changing the genetics of the plants and animals, they're changing the environment to create habitats for the various animals and plants they desire. And so it doesn't really matter if they're wild or not, and the whole concept of something being wild really doesn't exist. They're changing the environment to get what they want. And you'll see this in a minute. So I work in what's called the Llanos de Mojos, so the Plains of Mojos, present-day Department of the Beni in eastern Bolivia. And you can see here on this space image, you can see Lake Titicaca. If you've ever been to Peru, Bolivia, you see the dark area there in the lower left-hand corner. And this vast area of green. The dark green is canopy forest, and the lighter stuff is open savanna, or what we call pampa. And this is a seasonally flooded savanna. So the rains come for 4 or 5 months, starting about now, and rain continuously through April, sometimes into June, and then it all dries up. And so this creates an incredible dry landscape in what they would call the dry season, and a very, very wet, soggy landscape during beginning of this time of year. So you can see on this landscape, you can see an old cut-off river, water, sort of stagnant water. Areas covered with sometimes just a couple of inches, sometimes several feet along, especially the lower areas, especially rivers. But you can actually see some kind of straight lines and things in there. If you look at the center of the image, a little bit lower from the center, and then that weird straight thing there. And these are artificial patterns. These are not natural. And this is the kind of stuff that I look for. So the area I'm focusing on today is what we call Baures, and it's very remote. Until recently, didn't have any roads to it along the Brazilian border. And it's a wonderful landscape, wonderful people. And this is what it looks like at the end of the rainy season. So you see the savannas there, and these are sort of swamps this time of year, and then they dry out. And then what we call forest islands are slight rises. In some areas, they're artificial. In this area, most of them are natural. And this is all maintained by burning. They burn and burn and burn. Today, the ranchers, to get rid of all the old grass, the old dry grass that isn't nutritious for their animals, and the new grass comes up, and the animals get fat. In the past, they didn't have cattle, but they liked pampa deer and all these other animals that graze on those areas. And so essentially they're creating, through burning, and we know they did this because we wouldn't have these savannas and open areas unless they were burned regularly. So this probably goes back thousands of years, maybe even to the first peoples. And what they're doing with fire is not destructive, it's managing the landscape. And they're creating all of these different environments, a heterogeneous environment within an area that probably naturally, without burning and without human activities, would be kind of a simple landscape. The native peoples today, we assume, are some way related to the peoples of the past that I'm studying, and I'll be showing tonight. Some people try to take certain groups and say, well, these are the ones that probably built the earthworks. I'm a little more hesitant because we've lost lots of the records of some 40 different language groups that were in this area. Today it's primarily 2 or 3 language groups, but certainly these are the living descendants of these societies. So I'm interested in earthworks of all kind, and the ones that we sort of started working on were the agricultural earthworks that you saw, and you'll see a few more in a few minutes. My other colleagues are interested in traditional sites, so they're working on the settlement mounds. These are large, big bumps on the flat landscape where people piled up earth to live, and causeways and canals, all kinds of water management systems, of moving water from one place to another, draining it in some cases, storing it in others with big reservoirs, and then the ring ditches or the geoglyphs that I'll talk about. This was what we would call an anthropogenic landscape. There's virtually nothing here that we can call natural. Everything has been churned, turned over, soils sometimes several meters below the present-day surface, rearranging things, blocking water, bringing water where it wasn't before. And it kind of looks wild today if you fly over because there's so few people, but as an archaeologist, we can now show that it was highly tampered with by humans. And so I was drawn studying these raised field systems. And so the lighter areas are slightly raised platforms. They won't flood during the rainy season. These are very badly eroded. And then the darker areas between them are more humid grass, and those are what we call canals between them. And so I learned how to do archaeology, as most people did, in traditional sites. And so we applied many of the same techniques to the landscape. And so we did trenches across these features. So you can see the slight rise of the fields that are going from top to bottom on this, and then the sort of swales or canals beside them where they took dirt out in the past and piled it up. And we cut these trenches across to provide windows, sort of the inside of these. Sometimes we recover material that we can date. Sometimes they ate food there while they were building the fields, and it gets covered up, and we can maybe date a fire hearth where they cook their meal or something. Sometimes pottery gets thrown in as probably part of trash, an organic matter that they're using to sustain the production. And the soils tell us a lot about their management and creation of new soils through this incredible system. And so in the 1990s, we did a number of experiments with some Bolivian agronomy colleagues to actually put fields back into use to study them, because none of them are used today. And this shows sort of the ideal model of the fields during the rainy season with the water in the canals and the raised platforms, and then 2 communities that worked with us in the 1980s on some of these experiments. And here you can see why they were building these platforms. In the upper image is the middle of the dry season. This is a very large field, probably bigger than most of them in terms of height. That's Bill Denovan standing on top who discovered these things. And then 6 months later, the exact same field in water and plants, manioc and bananas. We did a number of experiments, dry season, wet season. You see the contrast of how these things would work. And we found that there was an interest in some of the local communities, but most of them are not interested in agriculture. They want salaried jobs. So a lot of the areas that we were working with in the early days in the 80s and 90s have moved to the cities, leaving many of these rural areas kind of somewhat unpopulated. But we did have some success, and then a Bolivian project run by my colleague who's an economist, Oscar Saavedra, actually worked with the European Economic Community, got funding to work with 4 communities, and they actually built their fields not by hand, but using machinery. And as far as I know, these are still thriving communities. And you can see they've got corn there growing on what is very poor soils, and they're producing the nutrients in the canals. That's actually blue-green algae and water hyacinth that they scoop out of the canals, let it grow there, scoop it out, and then mix it in as an organic amendment to the soils. So I'm interested in all kinds of patterns, and one of the things that I turned to after the raised fields was looking at what we call landscapes of movement. And so you see here this straight kind of dark line that crosses the savanna, connecting the dark areas there are forest islands. And you can see a whole bunch of smaller lines, most of them are perfectly straight there. So those are canals and raised causeways, so platforms of earth raised up. Some of them, we've had a couple that are almost as wide as this room. Most of them are something like 10, 12 feet or so, and 2 or 3 feet high. And you can see how these things might work as roads, because you want to cross these flooded areas during the rainy season, and without trees on this area, you get burned up in the hot tropical sun when you're walking miles across this open area between your settlements. So you can see these lines, straight lines, and they're showing up as dark because trees are growing on there slightly higher, and the periodic burns of the savanna leave those trees alone, so they show up as dark lines. In the past, they probably didn't have many trees on them. So here's how they would have worked. This is a reconstruction by Dan Brinkmeyer, a colleague of mine, does a lot of my artwork that you see in the talk. And so they're building a pedestrian walkway by raising it up, so you keep your feet dry, carry your stuff. They're wide enough so 2 or 3 people can pass each other easily. And they're using the canals alongside where they took the dirt out to build those things as waterways. And so you can skim these heavy dugout canoes across these areas, carrying literally tons of produce or people. And you don't need much water, just a skim of water. These things can slide across it. So another phenomenon we saw were these weird straight features that we saw over and over and over again from the air. You can barely see them on the ground. And they're straight, they've got to be artificial. They sort of cross one over the top of the other in some cases, and they're not raised, they're slight depressions. And when you go to look at them on the ground, they're about this deep, about this wide, just big enough for the base of one of those large canoes to pass. So we think they're using these as grand avenues, crisscrossing between the communities, their fields, and these ceremonial structures, or large earthwork structures I'll talk about in a few minutes. We use it to get around today at the end of the rainy season. For instance, how many of these do they need? So these are 2 forest islands, probably from one side to the other is about a mile or so in measurement. And you see all those straight lines there between them. So something intense interaction is going on between those 2 areas of high ground. So we mapped these things out. This is on old spy satellite imagery that we were able to get. It was declassified, and now we use Google Earth. You can see the number of those. We try to sort of color code them by their sizes. And we found in that one image there, I think we gave up after counting 200 of these things. It's almost as if everybody had their own private route to go maybe visit their relatives or friends on the other community. And we've mapped so far some 900 linear kilometers of these things. It's probably double or triple of that in the area. Many of them are well preserved, many of them are less so, but they're connecting forest islands in this schematic and the communities on them. I'll do a quick switch here. Another thing we noticed is that they're changing rivers, they're changing the flood patterns here that we assumed were all natural. And they're doing this through those same earthworks I just showed you. So this shows the savanna in the rainy season with about probably a foot of water on it. You can see these raised areas, those are causeways. And we thought, well, maybe these things are blocking or controlling water. So this became apparent when I took a trip. I usually go in the dry season. We can get around easy. I went one time to take my dad down there in December, and it was after heavy rains. The roads turned into just a quagmire of mud. And I noticed as we had to dig our bus out and actually gave up, and we walked to another bus at the end of this thing, that one side of the road had water higher than the other side. I'm like, what's going on? This is almost a flat landscape. And the road, the engineers didn't put enough culverts in or drain pipes. they save money or something. And so the road is actually acting as a low dam or dike to prevent the movement of water.